The power plants used at present are, for the most part, dependent on burning fossil fuels, such as oil or coal. Alternative energy seems to be the ideal solution to the global warming problems that plague us everywhere. Both the use of solar panels and the use of wind turbines has a serious drawback. They are intermittent. Definitely, sunlight and darkness are part of a sequential cycle. The same thing happens with winds, they are not constant, and long-lasting batteries for storing the energy produced have not been fully developed yet. Another energy source is running power plants on atomic power. Currently, all atomic power plants work using nuclear fission, in which a neutron is thrown against a heavy nucleus, such as uranium, and splits it into several lighter nuclei, in addition to releasing neutrons which in turn impact other heavy uranium atoms, thus starting a chain reaction, such as the one used in an atom bomb, although in this case the reaction is prevented from running wild, by means of complex control equipment. This chain reaction produces high temperatures, which are used to generate steam, which in turn drives a turbine, and spins large generators, thus producing electrical power in large quantities, using up a relatively small amount of fissionable material, about 1/millionth of the amount used by plants which operate on common chemical reactions, such as burning oil or coal. On the other hand, the chain reaction produces extremely dangerous radioactive waste which pollutes the soil and water and which can last for centuries, emitting radiation and toxic substances. However, there is still another solution, also based on nuclear reactions. Fusion, based on the union of two small atoms to form a heavier one. This system is based on combining two hydrogen isotopes, deuterium and tritium, yielding one helium nucleus and one neutron, as well as a large amount of energy. This reaction even occurs in nature, both in the sun and in the stars. During its operation, no hazardous waste is generated. Unfortunately, it requires two factors which are almost impossible to achieve: high temperature and pressure, as huge as those inside our sun, and they must be continuously supplied to the reactor. Under ideal conditions, the reactor can generate 4 times more energy it requires, and it does not produce any toxic or dangerous waste. This kind of reaction is said to be the energy source of the future, the ideal alternative energy, which does not depend on light and darkness cycles, nor on the constant flow of the winds. However, given its startup and sustainment requirements, it is still a very elusive form of alternative energy. For the time being, it is just the energy of a still distant future. I hope this video has been of interest to you. Thanks for watching and, please, subscribe to my channel. Shava Tareen.